In the last episode, we migrated the operating system to NVMe and optimized the storage. Today, we deploy the actual application stack. We're going to install Docker, clone our industrial hub repository from GitHub, and bring up 3 services with a single command: Flask for the web interface, InfluxDB for time series data, and Nginx as the reverse proxy. Everything containerized, everything reproducible. The same command works on this device, a replacement unit, or any server. Before we install anything, let's verify the current state of the device. ARM64 architecture confirmed, almost a terabyte free on the NVMe. Docker is not installed yet. Clean baseline, exactly what we expect. For Docker, we use the official installation script from Docker. This is the recommended method for Debian-based systems. It detects the OS version, adds the correct repository, and installs the latest stable release. The script detected ARM64 architecture and Debian Trixie, added the correct Docker repository, and is now installing the engine, CLI, and Compose plugin. Docker engine and the Compose plugin are installed. Let's add our user to the Docker group so we can run Docker commands without sudo. Let's confirm Docker is working correctly with the classic Hello World test. Then check the Compose version. Hello from Docker confirms the engine can pull images and run containers. Compose v5.1.4 is built in, no separate installation needed. We're ready to run our stack. Now we pull the application code from GitHub. We'll clone it to /op/alarm hub. That's the standard location for application deployments on Linux. The entire codebase is now on the device. Flask application, Nginx configuration, Docker files, everything. Future updates are a single Git pull. The application reads all its secrets and settings from a .env file. We have a template with safe defaults. We copy it and fill in the real values. We need to set 3 things right now: a strong secret key for Flask sessions, the admin password, and the Flask environment to production. The InfluxDB token will add in a moment after InfluxDB starts up for the first time. The InfluxDB URL is already set to http influxdb86. That's the internal Docker network address. Docker resolves the service name InfluxDB automatically. Nginx needs a TLS certificate to serve HTTPS. For this deployment, we generate a self-signed certificate, valid for 10 years, suitable for an internal industrial network. 2 files, the certificate and the private key. Nginx will pick these up automatically when it starts, via the Docker volume mount defined in our Compose file. This is the moment everything comes together. One command starts all 3 services. Docker is pulling the InfluxDB and Nginx images from Docker Hub and building the Flask image locally from our Docker file. It's compiling all the Python dependencies. This first build takes a few minutes on ARM. Every subsequent update will be much faster because Docker caches the layers. 3 containers started. Let's check their status. All 3 services are up and running. Flask, InfluxDB, Nginx, each in its own isolated container, connected through a private Docker network. InfluxDB needs a one-time initial setup before Flask can connect to it. We open it in a browser using the device's IP address on port 8A86. Organization Alarm Hub, Bucket Alarm Hub created. We generated an all-access token. This is what Flask uses to write sensor readings and query historical data. Copy this token. We'll paste it into the configuration now. Now we update the configuration with the real InfluxDB token and restart Flask. Flask restarted with the real token. The logs show the application starting up, the polling engine initializing, alarm engine ready, database tables created. No errors. Final verification. We test the HTTPS endpoint and open the application in the browser. 302, Nginx is running, HTTPS is working, Flask is responding with a redirect to the login page. Let's open it in the browser. The browser shows a certificate warning, expected for a self-signed certificate on an internal network. We accept it, and we're at the login page of our Industrial Alarm and Monitor Hub, served over HTTPS from a Raspberry Pi running Docker. Log in with the admin credentials we set in the configuration. The full stack is running, Flask serving the web interface, InfluxDB storing time series data, Nginx handling HTTPS and security headers. Everything in Docker, everything reproducible. If this device fails, replacing it means 3 commands: clone, configure.env, and Docker compose up. That's the value of containerization in an industrial deployment. In the next episode, we connect the first real device, Modbus TCP, and watch live sensor data flowing into the dashboard. Follow along for the next one.